right. So hope you guys have your computers set up because they will be coding. You guys have your computers. All right. So first of all, I'm gonna be putting you guys through one or two things that I feel you guys need to know before we start coding. Um Last week we did the intro to CNN and I explained the basic things for you guys. I remember telling you guys last week that there's something known as overfitting. So overfitting is a term in machine learning and deep learning, which has to do with an AI model doing the wrong things. So basically, what happens is that you train the AI model with a particular data set, and the AI model learns so well about that data set. And then when you give it another data set that is still the same thing, the AI goes ahead and does the wrong thing. So let me see if I can. It doesn't. It doesn't know that. It doesn't know that that data set you get to is the same thing because it has learned so much about the previous data set. It has learned so much about what you gave to it to the point where it can't even. If you give it another data set, if you give it that same thing in a different way, you can't tell it. All right. So, which is very very bad. Um, Let me in mesh classification. So basically, uh, I'm looking for a very good example. Okay, let me use this for example now. Let's say, for example, let's say, for example, I have this neural networks model that is an image. Then I'm sorry, I have this data set as an image. Then I pass it to a neural networks model. And then this neural networks model only got this image, and let's say it got only 2 or 3 images. And then it learned so well about this image and then gave us an output which tells us that this image, for example, is an image of a boy, right? It gave us an output. Now, I came and gave it the same image, but now with the image looking this way. It's looking in the opposite direction. Boy, still the boy, but now the boy is facing this way. Instead of facing this way, it was facing. Now, because the AI model have learned so much about this particular image, about the features of the image, and it learned to the point where it knows this image so well. If I give it another image that is the same with this, the AI model would predict it wrong because it overfitted basically. It learns so much about it that it cannot even predict another thing. So if you give it something else, it just gives you wrong results. That's basically what overfitting is. All right. So um so overfitting in image classification occurs when machine learning model learns the training data too well, including the noise and specific details, leading to poor generalization on unseen data. That's on data that it has not seen before. This means the model performs very well on image it has seen, but struggle in image it has not seen. And that's a big problem. Because if you give it the same image, but in a way it has not seen it before, it's going to not be able to know that that's the correct thing. And we need to be able to solve that thing in machine learning. And the way to solve this is by something called, one of the best ways to solve it is by something called regularization. So regularization is what I'm going to explain to you guys today. I'm just going to give you guys one or two regularization techniques and would apply it as we are building our machine learning model. So one of the basic regularization technique is data augmentation, which I explained to you guys last time, which has to do with more like helping us to increase data sets and play around with the data set, giving it different varieties so that the deep learning model can still be able to know if the cat is looking in the left direction, to be able to know that this is still a picture of a cat. All right. And then there's batch normalization and there's dropout. So I'm going to explain these three things and we'll end the talk. All right. So data augmentation is a technique used in artificial intelligence to artificially increase the size of data set by generating new data points based on existing data points. This is often done by machine learning to improve model performance. So if you see, for example, we have this one image, but we generated 1, 2, 3, 4, 5, 6 images from it. What did we do? The first thing we did, we rotate this image by, this is 45 degrees position, and we save it. We did the same thing again by -45 degree. We save it. We crop the image. This particular image, it has been cropped. It has been reversed to -90 degree. As you can see, this cat was looking this way and looking the opposite way. And then we crop it and save it. The third one, we save the -90 degrees. That's 180 degrees of the image. As you can see, it was facing this way, now it's facing this way, and we save it. We now rotate that same image by, this is I think this is 30 degrees. We did the same thing here again. This 180, we crop it again. So this is basically augmentation. You can, scale, you can apply, anything you want to, maybe blur, contrast, anything. That's data augmentation. With this, we have picked one image and then we've generated 6 new images from this. So if I train this AI model with this and I give it an image of this cat, it will be able to know that this is a cat. Not if I give it an image of a cat looking in a different way, to still be able to know that this is an image of a cat. With this, we overcome overfitting. Without it, we are going to train models that would give us wrong results. Or models that would know things it was trained on so well to the point where it doesn't know any other thing. The second thing is batch normalization. So batch normalization, I think last week I told you guys about normalizing, during the session, I told you guys about normalizing image, dividing the image by what? 255. Now, batch normalization has to do with normalizing input of layers, making sure that each of the node, they give out a normalized output. So what it means is, once we put in our input to our first node, the output of that node, all of them, they are being normalized, all the nodes, right? And we pass it to another node, and after that, we normalize it, pass it to another node. Hence, called batch normalization, because we are normalizing an entire layer in batch. So basically, I need hair. Yeah. So basically, what batch normalization does is that it normalizes the node. That's the result that comes out of this node, the output. It normalizes the output of the node before sending it to the next node in our neural networks model. And it's always done in batch, in layers. And that's why we call it batch normalization. Now with this, we'll be able to normalize our inputs and our outputs. And then with that, um, we can we can get a very, very good result. These things are very, very needed. So batch normalization is a technique that normalizes the input of each layer in your neural networks model. Think of it as a way to ensure that each layer receives input that is well behaved, meaning they are in a stable distribution with a mean of 0 and a standard derivation. This is just how it is being gotten. All right. This simple tweak can lead to faster training, better performance, and more stabilization in your models. Then the last thing I'll be explaining is dropout. So basically, what dropout does is, remember last week I told you guys about training model. So once you train this model, all right, you train this AI model, we have different nodes. We have different nodes. These are different nodes. And then this node passes the results to this one, passes its input to this, passes its input to this. But sometimes the node may be learning wrongly, or sometimes the node may overlearn, or the layers are too much, or the nodes are too much and they are learning, or maybe they are overfitting. So what we do in most of the cases is that we turn off some of the node during the training process. As we keep on training, we turn off some node. Let's say we choose to turn off this node. We turn off some node, and then those nodes are turned off, and the model passes and learns about some parameters, some features, and then we pass the result back again, and then we keep on randomly turning off node and dropping out some node. With this, we used to most of the time get very, very good performance. These are things you do to overcome overfitting. If you see, for example, in this case, we had this whole neural networks model, and then when we are training it, these are input layer, right? In the hidden layer, we dropped out two nodes. We dropped out, we turned off this node, we turned off this node. So the input now goes to this guy, goes to this guy. In the next layer, we pass it, and then we keep on randomly doing that. With this, we are going to get better predictions and better model training. So dropout is a regularization technique used in deep learning models, particularly convolutional neural networks, to prevent overfitting. Overfitting occurs when a model performs well on training data, but fails to generalize in new unseen data. I think I already explained this. Dropout addresses this by randomly dropping out, setting to zero a fraction of neurons during training, forcing the network to learn more robust and generalize features. That's dropout. And then the last thing I didn't tell you guys about is what is called validation data sets. Remember, I told you guys about training data set and testing data sets. So training, the data set that we put in, testing the data set that so let's say these are our inputs, right? We put in here, testing the data set that we check the outputs, the Y with. So we compare the Y, these are our Y heights, and our main test data set, and then get the result, and then we run it again. But sometimes you need that as the model is learning, is also testing itself or is checking itself with something. And that's where validation data set comes in. So validation data set is a portion of the data set that is separate from training data sets, right? Used in machine learning to tune hyperparameters, evaluate model performance, and perform overfitting by checking how well the model generalizes to unseen example during development, acting as a crucial checkpoint without testing. So when the model is training, when our model is training, so these are the different nodes that we have in our model. When our model is training, validation data set is that data set that is inside the that is being used in the training. Sometimes it's not necessary, but most time in computer vision it's always very, very necessary. That data set is being used to validate our training and also to tune hyperparameters to validate the model. So what happens is as the model is training, it compares itself with the validation data set and check if it is doing well. And if it's not doing well, it knows when I'm going to the next neuron, when I'm doing the next training, when I'm doing the next thing, I need to change this parameter. And with that, we get a very, very good model training. So for example, if you see in this case, we have our training model, training set going, and then as we are training inside the model, we're also validating with the validation data set. This doesn't have to do with the test set, right? After we finish training the entire model, this in the process, this validation data set helps us to tweak the model because we're also doing like some comparison while we are still training. All right. And then after that, validation data set helps us to pick the best model that does well based on the validation data, based on the validation set, right? And then we confirm with the test results. Is it doing well? Is it not doing well? And then everything happens. So these are very, very key things I wanted to tell you guys before we start coding. We're going to implement everything. So we'll be doing two things today. Today's session may last a bit longer. I'll first of all build a simple image classifier that will classify image of two animals, and then we'll now build it's going to be the same thing. I'll just change the data set. We'll now build a traffic light. All right. So Now, the first thing you need to do is what? Is to import TensorFlow to install TensorFlow. So all you do is pip install TensorFlow. Sometimes you need to install TensorFlow. Hope you guys are coding alongside. Can you see my screen? Okay. So while we're installing TensorFlow, we'll go online and search for data sets. So trend tests about data sets for image classification TensorFlow. So I'll find some data sets here. Okay. Let me see if I have. I actually have a data set I can share it with you guys. I downloaded it today. This data set here. Where is it? This. So I'll share it with you guys on the group right now. Let me see if it's the one. It's extracting. What's the highest I can share on Discord? Yeah. This for the traffic lights, and then this one is for the animal. So I'm not sure I can share that, but I'll upload it to a drive. Then I'll share you guys a link. File upload. I'll put it up in a folder. Ah, okay. One, and then the other one is this. Okay. So once it's done uploading, I'll show you guys the link in in the the comment section. All right. Okay. So now, does anyone have any question about this before while we are waiting for our data set? Does anyone have any question about this? About regularization? I'd like to get a question while I'm waiting for the thing to finish uploading, so I share you guys a link. Does anyone that have any question? Okay, no one has a question. So it's almost done. So while I'm waiting, I'm going to use this first data set. This one has a lot of images. This one here. So I've already unzipped it, and this is it. And then the second one is this one. So it has images of, let me unzip it. Okay. So it does these images of traffic signs, which we are going to use. All right. It has images of traffic signs, different type of traffic signs, 20. I don't know what those traffic signs mean though. I don't know what this one means. This one is, I don't know, I swear. I don't know. And then this other one is an image of two type of animals. Jaguar, and Cheetah. All right. So inside there we have the trend folder, which is where our trend data set is. We have the test folder, which is where our test data set is, and then we have our validation data set. Inside it, we have the two classes, the cheetah and the jaguar. So if you open here, you will see images of cheetah. You see? Sorry, jaguar. If you open here, if you open the trend data set, the cheetah, you will see there are a lot of images here, right? There are a lot of these like 900 images. The jaguar also is going to be the same amount of size. Mind you, the training data set, the two classes must have the same amount of images. All right. And then for evaluation set, they must also have the same amount of content. So if I try to open this one should have 16 images, and the other one too should have the same. Note, when you are building, when you are training your machine learning model, let me explain one thing. When you're training your machine learning models, let's say we have a data set, one data set. We have the data sets that's like this. These are 100% or 100 images. If you want to train, your training set should have more data sets. So let's say your training set should have 50 images. Your validation set should have like, let's say, 30 images, and then your test set should have 20 images. This is because this is training set is where our model learns mostly from. So we need it to be more. That's why I see that the training is 900, and then the validation is just 16, then the test may be even smaller. All right. So it's done training. So let me give you guys the link to this. So uh, share. All right. I'm dropping the link in the. All right. So that's the link to two of our data sets. Then I also drop it on the chat here. All right. So let's start coding. So the first thing I'll do is to get my data sets. All right. So I'm getting my data sets, which is this, and then I'm putting it here. Mind you, in TensorFlow, you must make sure that the folder of your data set is named images. Don't forget. I don't know if there have been recent changes, but what I know is that it must be named images. All right. So now we start coding. I'm going to create a file called model, and then I'll start. The first thing I'll do is to import TensorFlow. Import TensorFlow as import TensorFlow as TF. Also, we need to import some few parameters from TensorFlow.keras import layers. All right. Let me import because we need some things here from TensorFlow dot keras dot layers. Okay, I've done it already. We need to import conf2d, that's conditional to this. We need to import, we don't need to the transpose. We need to import max to the. Okay, that's here already. We need to import flatten. We need to import dense. We need to import dropout. We need to import batch normalization. All right. And then from TensorFlow dot keras, we need to import input and model. TensorFlow dot keras.
Can you
Import.
kindly zoom can you kindly zoom the screen?
Okay. Model. All right. Import inputs. And then we import model. And then the last thing, we need either OpenCV or Matplotlib. I love using OpenCV, so I'll install both Matplotlib and OpenCV. Pip install Matplotlib, and also OpenCV. You just keep a space, and then you put OpenCV Python. That would install two of them at the same time. And install Matplotlib. Oh, that's to be P. All right. So now, while I'm waiting for that, the first thing we have to do is very, very simple. Is to first of all tell it where our input data set is. So our trend part is equals to what? Our trend part is equals to this place right here. So I'll copy this absolute part and then I'll paste it here. That's the part of my trend data set. And then val part is equals to the same things, and they're in the same place, images slash val. And then the test part is equals to then test. All right. I assume you guys know what I'm doing here. I'm just putting test here. It's the same thing. If I copy this thing here and put it, it's the same thing that because they're in the same folder. All right. I need to define my epoch. I think I already told you guys about what epoch is. So I need to define my epoch. For now, we'll start with one epoch. So we test our model to know if it is even working. And then our input shape. So we need to tell TensorFlow what is the input shape of the image. Input shape of image. I remember telling you guys about last week that each of our images that comes in literally has shapes. All right. So let's say this is an image. We have a shape of X and Y. All right. So let's say this image is 20 pixel by 30 pixel, which most case is always not the scenario. Both of the time they always have the same pixel. So for us, we'll be using 100 by 100. So we'll define that our image is going to be using an 100 by 100 pixel parameters. So, but let's look at what the images as. By default, the images here, they are, what's the pixels? I can't know. Okay, let me see if I can get info. I can't get it. Okay. So this image is how many pixel by how many pixel? It's 400 by 400. But now since I have control, I want it to be 100 by 100. I want to pass it 100 by 100 pixel into my model, right? So my input shape, this thing just helping me, thank God. going to be equals to what? I'm using 100 by 100, 100 by 100 by 3. This 3 is what? Is the channel. Remember telling you guys about channels last week, meaning RGB. We're working with 3 scale image here, working with RGB images. That's why we are putting 3 here, right? Else we'll just put like one image. As I'm speaking right now, we're already defining our neural networks model. Now, this is our input. So we've started coding the model right now. We first of all, let me check if I have this spent. I'm not installed it yet. Okay. So we are about to start coding our model. So we need to decide what we want. All right. So clear. So we are going to have something like this. We're having something like this, which is our final model. But before we get here, we need to apply some simple CNN. Can I do Control Z? Control Z. So we'll do some simple things, which is like our, maybe bash num, max pool is going to be different layers before we flatten. And then before we pass it to the dense layer, which is going to be our neural networks model. All right. This poorly drawn CNN AI. Okay, so we'll be applying something like this. This is what we are going to be doing. So let me copy this image and then I'll just paste it here. So we are going to be doing something like this. First off, we have our input, all right? We have our input right now, which we already declared, which is this guy. So we declared our input is going to be what? 100 by 100, all right? 100 by 100. And then we'll pass it to the first convolution, which we will define. And then after this, we choose what happens here, which is exactly what we saw right here. After this, we apply batch normalization here, and then also apply max pooling as we decide. So we'd apply like batch normalization, we do some convolution, maybe we'll do pooling. Then after pooling, we do another layer. After another layer, let's say this is the first layer, and this we apply pooling here. We have another layer here. We apply pooling, max and batch normalization. We put another layer. We apply pooling. We do batch norm, and then we have our final layer, and then from there we flatten it, and then we pass it to our neural networks model. We are going to be defining all these things now as we are talking. All right. So we have our inputs right now. We have our inputs. We need to create this CNN layer. So to create the layer is very simple. All we need to do, we remember each of it, like we are passing it like step by step. All right. So what we'll do is our X is gonna be our first layer is gonna be what? Conf to D. This guy is just doing everything for me. Okay. So basically what is happening here is I'm telling it that I'm building a 2D computer vision model, right? That's what my my model is going to look like, all right? And then we have filter of 64, kernel size of what? 3 by 3, which I explained to you guys last week, right? Our activation function. Now, this basically just helps each layer to learn, to make sure it just helps each layer to learn. And then padding. I explained padding to you guys last time. We're using the same padding, and then this is not necessary. And now to tie this, from here to the next layer, we need to make sure we link two of them. So to link two of them, all you do is you just come and then you call the previous layer, which is this, our input. We call our previous layer, all right, which is input, and then we declare the shape of our first input. So instead of doing this, I'll just do this way. So after this first input, and what I'll do is I'll just say input is equals to input, and then I'll put the shape. So my shape is going to be equals to 100 by 100 by 3. Or I can just do shape equals input shape equals input shape. All right, what's this? Removal. Oh, this is a variable in Python, so this is going to give us an issue. So I'll do like this, capital I, then it should be input shape. Input shape. All right. What's going on? Remove call. Oh, messed up. This should be input. This input that we called here, and then we put the shape. Our shape is going to be equals to input shape. All right. And then we now call this right here. So I'll remove this. Our input will be equals to input. So with this, we'll be able to tie this our input to the first. So let me clear this up. With this, we'll be able to tie this our inputs to the first CNN layer, which is what we have right here. So we have our conf, we have a conf 2D, we have a filter of 64, our kernel size of 3 by 3, activation to be relu, padding same. Now after this, we need to do something in between, either max pooling, batch normalization, we need to do something so our model can learn. All right. So for me, what I'm going to do for this first, after the first layer, what I'm going to do is I'm going to apply batch normalization. So we normalize our inputs, our first input. So it's going to be equals to what we call batch normalization, which we imported, and then we link it with this first x. Mind you, we have this first x. We link it again. So from here, so let's say we have batch norm here. We're now linking it to this first guy here. We link whatever thing that's inside here, right? And it has been linked. And we need to put another layer. So I'm calling it X. It's going to be equals to what? This time around, I'm going with let me change this to 32 kernel instead. 32 this time around, let me change this to 32. And then kernel 3 by 3 activation relu padding same. I link it back to this X. You guys are understanding. So now we're in this second place. Now we've linked this to this, as you are seeing here. So we link this from here to here. Now we're linking this to here. And in between, we apply one or two things here. Now after this, we are going to pass this from here to the next convolutional layer. But I must apply max pooling. So we get, while we reduce the data set size, the pixel, we also maintain important features, because going on, I'm going to reduce or increase the kernel size. So I would apply max pool here. Now, if someone wants to ask, how do you choose these things? You just play around with it. Like, there are models out there that have like 3 billion parameters. So this is not constant. You can choose whatever you want. You can change this to 4 by 4, 2 by 2. It depends on you. You can change the padding type, whatever thing. All right. So now what I'm going to do, I'm going to apply max pool. So max pool 2B. Our pool size, mind you, whenever we do max pool, we must define the size of the filter, which is going to be 2 by 2. and then we link it up with X. So that's exactly, it's as simple as that. And then after doing this, one thing I'd like to do is that I'd like to apply dropout so that our model would learn. Our model would learn, and you know, it will be able to generalize, as I told you guys. So to apply dropout, I'll just do X is equals as you guess, dropout. Then I put in the ratio, right? So let's look at what that is. So our rates, that's the dropout rates, and then noise is equals to 0, CD equals to 0. So what we just put in right there is the rate of the dropout, was the rates. That's what I put in right there. Then we link it to X. Now, we may choose to do this over and over again. So I'm just this is my first official convolution block that I have built here. All right, this is my first convolutional block I have built here. So I'm going to do this again twice or 3 times. So I'm going to do this like 3 different times. So I'm going to build like, let's say 3 convolution blocks. So I have the first one here, I'll just copy and paste it. But at this point, I'm going to increase the kernel size. So why am I getting this error? It says duplicate code fragments. Okay, let me check what the issue is. Input shape equals push. Anyways, this is not necessarily an error, but let's we'll see where the issue is, and then we'll fix it. So, okay, so I'm going to change the kernel size here, the filter size to 64, and then I'll build another one. So I'll build another convolution block. Why am I getting this error? We declared X defined above. Oh yes, so I need to link this to X. Okay, correct, the error has gone. So I'll create another third convolution block, and this time around, I would make this, I'm going to increase the filter to 128. So this is something you can just play around as much as you want. All right, just play around with it. There's not much difference. And then I'll build the last one. I'm just playing around with it. You can go back, sit down, do anything you want. Let's try with filter of 156. And then this one with filter of 156. But at this point, I'm done. So I've created my neural networks CNN block. So we have like the first conf layer, we have the second conf layer, all right, and then we have the third conf layer, and then we have the fourth conf layer. All right, so each of these guys are going to be learning different features. Each of these features are going to help us to learn different features in the animal. And then the next thing we need to do now is to do what? Is to flatten, which is what is happening down here. So to flatten, what I'm going to do is I'll just do my X is equals to flatten. And then I pass it to X. You don't need to put any parameters. And then I'll link it to my dense layer, which is the main thing there. It's going to be our neural networks layer that's going to be performing the learning. In this place, what we are doing is just preparing data set, like, performing 1 or 2 things, trying to extract features, getting features that we want. This is where we are learning, right? So in the whole of this place, we are preparing data set. This is where we flatten the images, convert it, and then pass it to the main thing here, which is going to learn. So this is inevitable, this part here is very, very important. All right, this part down here. All right. Okay. So our dense layer, we now choose the amount of neurons, whatever thing that we want. So our dense layer, our first dense layer is going to be what? X is equals to dense. I'll set it to five one 12. Activation to be relu. And then after this first layer, I'll normalize it. I'll put bash normalization. Bash normalization. Then I'll I would apply dropout. So I would like to apply dropout here. Apply dropout. My dropout, I think I'll use 0.5. All right. Okay. Now these are numbers you can play around with. So you have right to go and do anything you want. And then X is equals to dense. Again, I'd apply. Okay, it did it for me already. I'm gonna apply bash num, then I'll apply dropout. And I think I should end there for now. I should end there for now. So my outputs. Now, mind you, our data set is of two categories. We're having just two categories of cheetah and jaguar. So this output here that we are going to have here, the final node, all right, the final node must is a must. It must be of only the amount of um the amount of output that I want. That's the amount of results, the final data set, the amount of data set that we have. So in this case, we have only two. So this last layer that we're going to define must be only two, should have only two nodes. That's what I'm going to do here. Our output is going to be equals to our unit must be two because we have only two data sets here. So activation should be softmax. Now, why are we doing this? Because we've trained our model, we've declared our model, all right, and now we need to link it to the final data set that should be able to tell us our final result, right? That is our output. That's our output node, and then the activation function that we use here that I choose to use. There are a lot of them. There's sigmoid, there's the rest of them, but I'm going to use softmax for the activation. If we are bringing like something that can classify very binary classification, you can choose to use sigmoid there. All right, and then that's the end of it. We have built our model. Now to tell TensorFlow for us to summarize our model, for us to build our model, we just do only one thing. So I'm going to write model here equals to, we call model that we defined. So our input is going to be equals to input, all right, which is this input here. So this is the input shape, all right. So now that's the first thing that we are passing in, all right. Then our output is going to be what's this final output, all right. And then we can decide to see our model. So I'll just do model dot sum, model dot summary, model dot summary, and give us that should be able to build our model for us. So I can print this, so print model, and then let's see what we get. If we get an error, we fix it. If there's no error, then we're good. Okay, it's validating. Let me reduce this a bit. So while we are waiting for that, let me explain it again. So these are convolutional neural networks. These are CNN layers from this place down to here. These are CNN layer. We play around with it. We choose our kernel size. We choose what we want to do. We choose how we want to regularize it. and then we apply dropout whatsoever. You are free to play around with it. Then after that, after choosing the amount of layers that we want, we now apply a dense layer. We flatten it, and then we apply our dense layer, which is our main neural networks layer here. And then we put a dropout, and then we pass that to the final dense layer, which the unit, which the node must be equal to the amount of data set that we have. And then we use this to call TensorFlow to build the model for us. Okay, so let me check if I can find okay, this is exactly what we are doing here. So let me put this here. So this is exactly, then this exactly explains more. So what am I saying here? We have our first input. Our input comes in here. All right. Our input comes in here. We pass the input to the first convolution layer. And then in between this first convolution layer, we do like padding. All right. 2 by 2 padding. We pass it to the next convolution. We do padding. We can play around with it, do anything we want. Pass it to the next convolution. We do pulling anything, and then we flatten. Then we pass it to the output. Let me check if there's another good explanation. But I think that explains it more. That explains it more. Okay, let's get back to our code. All right, so it's done. So if you see, these are model summary. Is the model that we are building. So first of all, we have our input layer to be this 100 by 100 by 3. Our first conv layer is 100 by 100 by 32, which we choose as the filter size. Our parameter, we normalize it, bash norm, and then it reduce our parameter reduce. So we go again, we pass it to the second conv. Our output size is what? 100 by 100 by 32. Parameters increase, pass it to max pool. We remember when I told you guys, once we apply max pool, most of the time it divides our inputs by 2. So as you see, our data set has reduced. That's reduced to 50, right? And then we apply dropouts. Once we apply dropout, I increase the parameters, the filters again by 64. Our output shape is still 50. We apply max pool again, it cut it by 25. After the second conf, layer, all right, and then we apply max pool again, all right, and then we apply dropouts, and then we apply, this is second conf, this is fifth conf layer, all right. We apply dropout, we apply max pool, reduce from 25 to 12, we drop out our filter, remember we use 28, we apply bash norm, and then you keep on playing with this as much as you want. After everything, we max pool, I think we max pool here from 25 to 12, and then we apply max pool again, it went to 6, and then we apply dropouts, and then we flatten it. Remember I told you guys flatten, we do this times this, I think times this, it should give us this value. And then we pass it to our dense layer. All right. And then we normalize it, we drop out, pass it to the second dense layer, we normalize, we drop out, then the last dense layer. So this is the total parameters. All right. And that is our model. So that's just the first stage. So now we need to train the model. What do we do to train the model? We have to pass our data sets from this input that we have here. We have to pass our data set to the model. We need to start linking up everything. So now to train it, we need to augment the data set. We need to do data augmentation. So to do data augmentation, mind you, what we did down here was just we are trying to extract and get features, right? What we are doing is that we are doing feature extraction. We are trying to make it to learn to get some important features, to max pool, to do heaven and earth. But for us to get our model to be very, very smart, we need to also do regularization, and we need to do augmentation. So for us to apply augmentation, we need to do things like flipping, vertical flip, share range, a lot of things. So what do we do? So train data generation, I'm gonna call it this way, because to augment, TensorFlow already has a default function for us, which is image data gen. Inside this, we are going to put a lot of things. First of all, we need to scale. So rescale is equals to, as you guys saw last week, 1 divided by 255, which I explained to you guys what it does. The next thing I want to flip the image a little bit by maybe 0.4% horizontally. So I'll just do a horizontal flip is equals to, I'll use 0.4, 0.4. Then vertical flip, I can do the same thing, 0.4. And then I want to zoom into the image a little bit. So I want to zoom in. So zoom range, I can zoom in 20%. I want to rotate it by 90 degrees or 40 degrees. So I rotate it by 40. And also I can apply something called width shift range and also height shift range. These are things that Python will just help me put in automatically. And then fill mode. So fill mode basically is just helping me to fill in, maybe if something is missing, you can just pick the nearest pixel and fill in for me. I think I'll stop there for now. Thank you. Please don't help me again. Now that's for the train. I've applied this augmentation on the train data set. I need to apply it for validate data set. So for validate data set, um, we'll do valid data gen. This one, you don't need to do too much augmentation on it. You don't need to do too much augmentation. If you just do rescaling, which is very, very important, is enough. We just rescale it. That's enough. And then we do the same thing for tests. For sorry, this is for the validate data generation, and then we are done with that. Now the next thing, I'm not going to do this test one yet. All right. The next thing I need to do is for me to hello, can you guys hear me? Hello?
Yes, we can hear you.
All right. So one of the things that we can do is that um we need to be able to label our data set. Mind you, I told you guys about labeling. So we need to be able to tell it that this image I'm passing here, this first image is a cheetah, this second image is a jaguar. And this takes a lot of stress because I need to be able to tell it, I need to be able to write some programming thing that will first of all give me data set and then I link them up one by one. With TensorFlow, we don't have to do this. We can automatically label it for us. All we have to do is just that we have to put that's why I decided to use email TensorFlow. All we have to do is that we have to put the data set in the image folder. We put it in the correct proportion, like the trend test, and it automatically just picks the folder name and automatically labels it for us. And then once we are training, it refers it like 0, 1, and the rest and the rest. So how do we do this? Very simple. It's what is called train data flow. Train data flow and flow from directory. Right? There's something called flow from directory in TensorFlow. So what I'll just do is I'll do train generator is equals to thank God for Python. So we just call this our train data set, that this augmentation that we did to flow from directory. Simple. And then what I'm going to pass in there, I'm passing the batch size. What does batch size means? Batch size means the amount of data set I'm passing it at once. So in this case, I'm going to pass in just 32 data sets at once. So it means when I'm training my neural networks model, how many of these data sets am I going to patch at the same time? So I'm going to say I want to pass in 32. You can choose to pass in everything. You can choose to pass in 2, 2. The smaller you pass in, the longer your model takes to train. The more you pack in, the more you pass in, the faster your model takes to train. But as you know, if you pass in a lot, all of them at the same time, the model will not learn well, right? So we just need to pass in a little portion. So 32, and then um the target size. So I need to pass in target size. That's the size of the image. So target size is going to be 100 by 100 because our image is 100 by 100 pixel. And then um um I'm going to just pass in class mode. Class mode, I'll use categorical and then shuffle. Now, shuffle, what it does is it shuffles the image, right? It just shuffles the image. And then there's something TensorFlow. There's one thing we can do is to pass in seed. And then our color mode, very, very important. Our color mode, we are using an RGB image. So we put in here our RGB image. Now we are going to do the same thing for we're going to do the same thing for our validation generator. So the same thing, I'll just copy the same thing and paste. There's an error here. Let me check it first. Parameter directory undefined. Oh yes. So I need to define the path to my image. So trend path is going to be equals to what? It's going to be equals to, I think we have trend path. Okay, I'll just write it this way. So that's going to be the part of where it's going to locate the image from. So I'll just do the same thing for the validation set. And that is it. So I'll do val generator equals to this will be val part, and then it will be val data gen flow from directory. Our bash, I'll do 32. Okay. So it's as simple as ABC. So now we need to train our model. How do we train the model? We just do a simple thing. TensorFlow as a function called model.fit. This guy, this guy's already done everything for me. Model.fit. Then passing my trend generator by epochs. I'm going to choose my epochs. Wow. Epochs validation data set is our validation generator. All right. And that is as simple as that. And then we need to save the model so we can use it. So just the model dot save. I'll call it model.h5. And okay, I would like to print I would like to print the way the thing is learning. Maybe like I would like to print the model training versus the epoch versus accuracy and all those things. So I would just like to save this in history. I'll use it later. All right. Okay. So we'll test this with one epoch only. Let's see if it will work. If this work, then we are good. Okay. Okay. Thank you. Model of fit. No, it doesn't have anything called model of fit. So okay. Hmm. Let me check. Model. Hmm. Okay. Um, so non-type object as model. Am I spelling it wrongly? That should work. How did we define our model? It was model equals this. Okay, let me remove this. Okay. You must call compile before using model. Um, oh yeah. Okay. Okay. So after this summary, I forgot to add something. I need to compile the model. So model.compile, and then the loss I'm going to use. There are a lot of loss you can use, but I like to use categorical cross entropy, and then optimizer. I'll use Adam optimizer. Remember, I told you guys there are a lot of optimizers you can use gradient descent, and but these are the most popular. Then our metrics will be accuracy. I think it should run now. Should run now. Should run now. All right. Okay. So it found 18,000 images belonging to two classes, and then that's for the training set. And then for the evaluation set, it found 32 images. Okay, let me try something. Mm, tests. Sorry. Let me put the was of this in Skippy. Yeah. Pip install Skippy. Mm. All right. Okay, let's run our model again. If this works, then we'll just train it 10 times and we try to test. It should work. I'm 100% sure it should work. Uh-huh. All right. It worked. All right. Okay, let me hold on a bit while waiting for it. Does anyone have any question? Does anyone of us have any question? I've been talking to myself. Hello? Okay, it's done.
Yes,
Model has
I can hear
run,
you.
and then it saved the model. Yeah, correct. So I'm going to delete this now, and then I would train it like, let's say 100 epochs. Epochs equals where's the place where I have to fit it? Okay, let's do 50, and then we run it. So while we are waiting for that, I'll just write a little script um, that is going to help us test our model. So I'll just write predict. So to predict, it's just a very, very simple thing. And one sec. I think I'm missing something. I'd like to print the results so we see how the model is learning. So to print that, I would use matplotlib. I have a code here that can that should help us. So I'll just copy it and paste. All right. So basically, what happens here is, first of all, I need to import. Okay, correct. So I'm importing matplotlib.plt. It's going to help me to print the accuracy. So first off, I want to see the epochs. All right. So I'm going to get it from history. I'm going to get the epochs from history. And what I'm looking for is I'm running it to get all the epochs because I want to print it. And then I also want to get the validation. I'm checking against the training data and the validation data. All right. And then this is me just labeling the different positions, the X and the Y. And then I'm using this to plot the epochs, to plot the data points. All right. And these are the labels. And I'm using this to show. And I'm going to save it in modeltraining.jpg. So I'll return this to two epochs or three epochs. So we'll see the training and see the result. Okay. This is the first epochs over three epochs. So the reason why I had to use this first data set because it's a little bit smaller and it's more faster to train. Then it's time we go on with advance. Hope you guys are enjoying the class, so I'm not talking too much. I know I'm playing the things like I'm breaking down the things. All right. Um. Mm-hmm. All the time. Wow. We thought all these things in. It's already 1 hour 25 minutes. No way. We must finish this thing before we leave today. Okay. All right. This is the result. Our model is doing so poor. Okay, let's see. So this is the model in respect to epoch. These are training accuracy. Oh, as the epoch is going, the accuracy is increasing. Okay. But for the validation, it's poor. Okay. For a lost data set, the lost is our model is poor. The validation as our training is increasing, the the accuracy is increasing for the test for the training data. For the validation data, the accuracy is reducing. This is poor. For the loss, as our training is increasing, the loss is reducing, and then the loss increased again. This for the validation data set. And then for the training, it reduce. Training is doing well because the images are much, but validation is just 16. All right. Anyways, so One more thing I need to teach you guys is something very, very important. It's edge computing. So you see that this model that we've trained, if we use it to do something in the real world, the model it will work, but you can't run it on mobile phones, you can't run it on Arduino, Raspberry Pi, and the rest of the thing. So we need to be able to have something that we can use it on light devices. Like you can put it on Raspberry Pi and it run fast. You can put it on your small HP to run fast. And that is where TensorFlow Lite comes in. So TensorFlow Lite um helps us, is going to convert this our model, all right, to a light version. So with that light, although we are going to miss some little accuracy, but it's always very, very important, especially in today's world, except maybe we have big GPUs. So I'm going to show you guys how to do that. We need to load this model and convert it from what it is to a light version. So with that, we can put it in Arduino, can put it in Raspberry Pi, we can put it on a small HP and it will run fast. Because imagine if you are training an image with like 20,000, a model with like 20,000 images, you can't, the model itself is going to be heavy. So if I go into my folder now, and then I want to check for the size of that simple thing that we trained, just look at what the size is. Go. So that simple thing that we trained, if I open it, this is the place inside here. Daniel Samuel. So the model is how many MB? 74 MB. Just three epochs. Only three epochs is already 74 MB. So let's say we train for 10 epochs. Or let's say we train for 6 epochs, it will be 74 times 72 times 4 times 2. That was already like 100 and something MB. If we train for like 500 epochs, which is always the case in most of this, 1,000 epochs, this will increase to like 500 MB. So we need to be able to put, because in that situation we can't run that model. We can't use this model in a very, very small device. It won't run. So we need to be able to use this. We need to make it in a way that we can use it anywhere and it will be fast. That's where TensorFlow Lite comes. And I needed to teach you guys this, because if I don't teach you guys, you won't be able to know what happens behind YOLO. Basically, YOLO is, I think, basically YOLO is just light model running. That's why YOLO is running very, very fast. All right. Okay. So to do that, we just do very, very simple thing. I'll do my model, be equals to. Also, there's another thing called early stopping. So you guys can write that down. You can review about it. Early stopping helps you that, let's say if our model is learning, the accuracy was increasing, and then at some point the accuracy started reducing. The model will look and then see that the accuracy is reducing and then stop at the point where the accuracy was correct. So, but I'm not going to implement that. And then the second thing is checkpoints. So checkpoint, basically, you can write it down, helps in, let's say I'm training the model and then my computer goes off. I need to be able to come back and continue training from there. And that's what checkpoint does. So checkpoint is, as the model is training, the place where the model was most accurate, the model saves it in a checkpoint file. So when the model accuracy increases, it saves it. So when your PC goes off, for example, if you're training, you can come back and then you continue training from where you stopped. But for today, I'll just teach you guys about converting this from what it is to a light model so you can use it on small devices. So I'll just do TF, which is TensorFlow that we imported, dot keras. We need to load the model that we just trained. So I'm going to call model, save model. Saved is equals to this. So I'm going to load the model. So we'll load the model, and then after loading it, we need to save it. All right. So I'll just do TF. I need to save the model somewhere. TF dot saved model dot save. So I'm going to save the model that we trained. All right. So I'm saving the model that we trained. Okay, one sec. This is meant to be the model. Did a mistake then. Model name should define model name. Model name equals to model h5. Model name. And then saved, I'm gonna put in the model name there. Then tf.save model.save. I'm saving my model which I trained in the directory which I want to save it. So I can just save it in here. And then what else? I'll convert it. So to convert, I'm going to do tf.light tf light converter from Keras. Yeah, I'm saving the model. All right. Is there anything I'm getting wrong? Tf light dot this converter dot from saved model. Then I'm putting in the directory of the model. Let me see what does it need there. Save model directory. So I'll just save it here. And then converter, which is convert dot need to pass in the optimization. Optimization is equals to tf.light.optimize default, and then the last thing you do is you do convert dot convert. And we need to write it. So I'm going to save this as file is equals to this. So we are trying to open, the file name would be model tf lights. We are writing it. I'm going to write it to something f.write this, and I'm writing it here, and that should work. So I'm just going to copy this out of here because I don't want to run the training code, so I'll just put it and then I'll test it. Import TensorFlow as model.save model name. I don't think I need this, do I don't. Okay. So let's try this and then see what would happen. Okay, unable to open model.h5. This is it. What's it saying? Unable to synchronously open file. Unable to open file error. No such file or directory. What do you mean? Okay, let me create a directory to save the model. Model save. So directory will be model save. And then I'll put model save. Let's run it again. Mm. Okay. Let me check what the issue is. Then send in HTA file. Mm-hmm. Number two single audio file. Number two file. Okay, one sec. Mm-hmm. Let me check out this and see. Right model dynamics. Mm. Oh, no way. The model is not saved in. Look at what I did. Not in the same path. This should work now. It's not in the same path. Let's see. Read only file system, model save. What do you mean? Mhm. And then this is meant to be. Okay, that's worked. So this place right here, I'm meant to define the name of the model. And what I wrote here is model self. Did I write any wrong thing? Model self. Did I write anything wrong here? It worked now. All right. But what we are looking for is this right here. This last model. This. So I'm going to delete this. I don't need this. Um, I don't need this save model, whatever. I don't need it. So all we need is this right here. Model.tf light. These are light model. So let's go back to the folder and see what we have. Um, um, I think I was even looking at the wrong thing. This 74. Okay, so what have we reduced it to? 32 kilobyte. Whooping 32 kilobyte from 74 to 32 kilobyte. That's the power of converting the model to TF light to quantize the model. By the way, what I'm doing is called model quantization. So this was very important for us because without this, we'll just be building things and it will be too heavy to run. So what I'll do is I'm going to go back to the model and I'll start training the model, but this time with 50 epochs or let's say at least 30 epochs. And then we hope it does fast. While that is happening, we'll use the model that we've quantized. So, what's the problem? Image trend. What did I do? No such file as image slash images slash trend. Okay. It's coming from this line. Trend part. Oh, oh, yeah, the model is now inside. Yes, I need to copy the actual part. Okay. And then var. This test, we are going to use it to test our data, our model, although we're not using it yet. Okay. So let's try to run a simple prediction while that is training. So to run a prediction, what we just need to do is we call that model that we already trained, this TF line that we converted. So I'll do if convert equals true. So if convert, then would convert it. If not, if it is false, then it won't convert. All right. Oh, okay. And I need to delete this too, because we need to get a new model. Yes. Okay, it's already training. So to test it, all I'll do is I'll use my model, my quantized model is equals to a model is called model.tflight. And then I'll interpret the model. So interpreter is equals tf.model, tf.light.interpreter. I'll put this model part. And then what I'll just do, just interpreter dot allocate tensors. And that is it. So we can now run a simple test with it. So to run a test, what I need to do is just to pass in, these guys are just helping me. So I'm going to pass in my input data set. So I'll just do, what I'll do to get it is just interpreter dot get input details. And then to get my outputs, right, I do interpreter dot get output details. And then I'm going to pass in the input shape. First off, I need to set interpreter dot set tensors. All right. Now I would pass in the image. So to pass in an image, I can use OpenCV or I can use yeah, I like to use OpenCV. So what I'll just do before I get here, I'll process the image first. So I'll write a function to process image. Def process. Okay, good. So I'll pass in my image. First off, I'll just load the image. So let me change this to, need to import a model from TensorFlow dot keras dot pre-processing. I want to import um I'm going to import image. All right. So what would happen here? Just I need to load the image first of all. So image is equals to image dot load my loading my image. The target size must be the same size as what you use for your training. So for our training, we use 100 by 100. Target size is 100. And then we now need to get the image array. Going to be what? We convert the image that we got to an array, right? And then we resize the image. We resize the image using, we can use OpenCV, we can use anything, but I like to use OpenCV. I think we installed OpenCV and put CV2. So I resize with CV2, CV2 dot resize. I'm resizing the image array that we got to 100 by 100. And then need to normalize it. That's normalize the image. So image array is equals to image array slash 255.0. All right. And then the last thing I'll do is to expand this. Need to import numpy. Import numpy as np. So then I return the image array and I can use this now. So I'll come down here. What I'll just do will just be to pass in the image that I got. So I'll say process image is equals to, so I'll put in an image here later. Process, put in an image that I'm going to use. And then I can now use this. So all I need to do here is just to come and tell this guy in this place, this thing I did down here, I need to pick it and it's meant to come after this. So input details, this in this place, I'm meant to pass in the image. That's why you're seeing it create this array for us. So processed image. Or let me just call it image array. I'm going to pass in this image array. And then I'll just invoke interpreter. And that's it. So our output data, our output details should be equals to interpreter dot get output details. And we'll do the same thing we did here again. Input details 0 index. Just follow along. Okay, so what's the error? Let me rename this to output data. The output details. Okay. Am I getting an error here? Interpreter.get. Should set tensors. Parameter on field value. What am I even doing? I'm getting the tensors. Interpreter.get tensor. All right. And then the last thing we do is that we're going to predict. So predict is going to be equals to what? This guy right here is going to give us our output. So I can print the output. So let's say I want to print output and then we see what to do. But I need to pass in an image. So I'm picking an image from the test and then I'll put it here. Let's see what it will give to us. Okay. Give us nan. Okay, that training was so poor. Anyways, training was poor. So, but let's tell it our label. Our label, the first label we have um is cheetah, and then the other one is called joker. Because we're going to use that right now. Jaguar. All right. So now I want to be able to print these labels accordingly based on what it predicts. So what I'll just do will just be to do read is equals to I'll use numpy. So I'll just do labels. The guy is coming to save the day. np dot argmax and then my output data, and that should give me the labels. And that's correct. So what's the issue? Let me check. Alias is not generic or already specialized. Anyways, I don't know what that means, but I know what is there is correct. So let's test it. If there's an error, we fix it. Okay, it got cheetah, which is correct, but try let's try with this. That's correct though. But let's try with this. Let's try with the second image and then see it to do well. Cheetah, you see, it's wrong. So now we need to train our model and make sure the model is very, very correct. But one thing we can do is that we can we can try to show so there's going to be visibility. So I can do like cv2 dot im read. That's to show our image. So I can give image of the image equals to cv2 dot im read. I'm reading which image? I'm reading image part, which I need to come here and define name part. Hey, I never used to take all this long, but it's okay. Is equals to this. I'll carry the whole of this, the whole of this like this to here, take it out, Control X, impact. Then I'll put it here. And then pass it. So we'll just do cv2.imread, cv2.imshow, so we can see our image, and then cv2.wait key 0. So we see the image, the thing we are working with, and what it predicted. We can show it here. Let's do something. CV2, let's do CV2 dot rectangle. CV2 dot sorry, dot right. Is it? The text. Now let me check. One sec. Forgotten. If it will put text and then we'll be putting, can you just help me please? I think this time I need you to help me the most. Image, since should automate this thing. String, our text should be, we're going to do string of what the prediction says, what the prediction says. And then the next thing is what are we seeing here? Text, hawk, that's the origin. So the origin of do 100 by 100. That's gonna be in a very bad place though. And then the next thing is font face. Oh, thank you. Thank you for helping me. Font face, font scale, color, thickness. Okay, I'll change this to 2. I'll change this to 1 so the image could stand. Then let's see what it tells us. The image is showing on my PC, but it's disappearing. So one thing is missing, CV2 destroy your Windows. I think that's where the issue is. Let me take this back. Oh, okay. So this is what I'm seeing. This is what I'm seeing. I'm not seeing the label. I'm not seeing the label. So what's going on? I'm not seeing the label. CV2 that that might even bring. It's meant to come after I'm finished writing the text. Okay. Now we should be able to see the label. Uh-huh. All right. Okay. It's showing. So it tells us that this is a cheetah, which is very wrong. Anyways, let's wait for the model to finish training and then we'll test the new model. We have just 4 epochs to go. By the way, let me confirm if I've not been talking to myself. This is getting to 2 hours now. Can you guys hear me? I'm now left with 5 people. No, 4 people more than the host. Can you guys hear me? Are you enjoying the class? Talk something on mute, on mute. You stay here.
So we'll still
Where
go
is he
over
going?
it. I'll still go
Computer
over
Vision
it.
Africa. Being I'm going home. One sec. All right. I think it's done by now. Anyways, this thing I have done, you can do it anywhere. Like you can use it to build any image classification model. That's why I had to like explain it bit by bit. This thing that I've taught you, you can use it to build any image classification model at all. This is what I used to build, and it's more easier to do with TensorFlow because some things are already defined for you. All right. Okay, so let's wait for this one to finish and then we quantize it and then we test. Please be fast. Okay, so I'll set this to true so that once I run it, it will just quantize the model at once, and then it will test it for us. Then I should delete this. That should be the okay. Should we continue with building the traffic sign? But it's just the same thing. For the traffic sign, it's the same model architecture. All right. Only difference is when you get to this end, here, which is in this, where is it? Where is it? Where is it? Where is it? When you get to the end of the model, you're passing, for example, in that particular data set, we have, wait, the model didn't save. No way. What did I do? Wait. Oh my goodness. Where's model.save? I moved it. Crazy. Ah, isn't that beautiful? That's nice, right? Anyways, let me do it again one more time. Yeah, for the traffic light, what you just do is, for example, in this case, we have this data set to be 43 items, starting from 0. So our last dense layer will be 43 items. Anyway, we need to put the amount of data set we put in 43. So I can automatically convert this to 3. So I can convert this to like to 3 data set, which would be trend. See, that's 1, that's 2, and then the third one. Then I can just create a new folder, call it images. Without I've created 3 data sets, although which is very bad. That's not what I'm meant to do. They are the same images. But with this, I have this guy, I have this, I have this. I can rename this to trend test val, right? Oh, that's wrong. Oh, wait. Oh, it should be this one. Okay. Um, can you hear me?
Yes.
All right. Okay. Anyways, just hold on a second. I mistakenly delete the code. So we have to wait for it to finish training again. Or do you guys understand? Do I end it here?
Sorry?
Do I end it here?
I want to suggest maybe when it's finished training, you can just help us send it to the group so that
Sorry?
I said I want to suggest. Can you hear me?
Very well.
Yes, if it's possible for you to just help us send the document, this file, I mean, to the group so that we can see.
Uh, I'll try, but just give it like 20 minutes. Let it finish training. Or let me reduce the epochs to 20. Or do we wait?
Let's
Let
wait.
me see if I can zip it. Sorry? What do you think? Do we wait?
Yeah.
Okay. Okay, so while waiting, I'd like you guys to next week, sorry, today is the last session for this year because CodeCamp they want to like end it for the year. So I'd like you guys to give me your general feedback, like if you've been able to learn anything from this boot camp, what have you learned? What do you think? Anything? Yeah, I'm listening. But we'll still resume next year, though. We're not ending, but they need to go on Christmas. I'm listening to you guys. Hello,
Yes, I can hear you. Can you hear me?
very well.
Yes, me, I've learned a lot. I've really learned a whole lot. Like, CNN to deeply. So at this, almost all the back end that you have got. What happened? Like, under the hood, the bossing and I think I understand it perfectly now. At least to a reasonable extent, let me say perfectly. But to a reasonable extent, I understand it. And the mode of teaching, I think, is very good because so far, most of the trainings I've attended, it's like the approach you use is really very, very okay because it forces somebody to actually go back to read more, to actually learn more, to understand everything like line by line. It's not like you go and copy ChatGPT and come and submit assignment. It's not work here. So that's really helps me. Thank you very much.
Okay, Victor, how about you?
Yeah, good evening. It's nothing much different from what Lord Tosin has said. So the highlight for me is the explanations of the code. So personally, I know much about the theory already, but due to school and all, I've not really had time to do more of coding. So, but this has really been very, very instrumental in helping me do that. So I feel we can continue with this approach towards for every exercise, one needs to know each line of code. So this approach is quite commendable. Yeah, thanks.
Oh, yeah, now I'm going to save it. So I'm going to save it because of the next cohort that we'll be having. Because we'll be having another cohort. But I was telling these guys that by next year, what we should do like an advanced computer vision. Like instead of like you guys continuing, we add more people, but now we do advance. Although I'm going to arrange things because when we come back next year, we'll be building like a lot of crazy things. We'll be building object classification, image classification, and the rest of the thing. But it'll be all advanced. You know. So Friday, you guys will be having a joint session, which they say I should be there. I don't know if I'll be able to make it sure, but you guys will be having a joint session. On that joint session, would be able to you guys will be able to talk about where you've learned and what you've not learned and the rest of the thing. So I hope you guys are going to make it there.
It's sorry, but can you hear me?
Yes,
The
boss.
advance that you're talking about, I don't understand. Can you please
Advance
explain
is big. Oh.
uh, like how advanced?
Like we aim to build a startup from this bootcamp. We aim to build a startup from this bootcamp. So we are looking at building things like real-time image classification, real-time image segmentation, image object detection, traffic light detection, um, fall detection, vehicle class classification, like all these things, weapon detection, all those things. Like when we come back, we'll be doing more projects because I've already handled all the basics right now. I think I'm even fast. I just discovered that I'm even more faster. I'm very, very fast. So when we come back, we'll be doing projects throughout. We'll be coding projects, we'll be building different projects, and I'll split you guys into different groups. So
Please, I still have another question. Please, how can we get data sets? Because I think I'm having issues with data
data
sets.
set you search for it. You see the way I just search for it on Google, or you find them yourself. You guys are enjoying Nigeria. Everywhere is on fire now.
That's not enjoyment.
Oh, yeah, let's wait for this thing. But you guys understand, like when I say you can now train, even if it's like 50 data set, all you do is just put them in subfolder and then you put them under images. TensorFlow will find it automatically by himself. Do you understand that? Okay, I think I'll end the meeting right now and the recording while we wait.